All right, we are going to be talking about 6.1, which is the law of sines. The law of sines is a very easy concept. It is not difficult. I will say, if you open up your textbook to page 394, I believe, 393 through 395. They have some unbelievable examples. It is not difficult to follow. It is very easy. I've already placed it on Google Classroom for you. You can see exactly what I'm talking about whenever you look at these examples. They have every single thing in here. It is easier for you to look at the examples than probably to watch a video.
Yeah, it definitely is when you're.
You should do that. Okay? These examples tell you step by step how to do it, and they are very, very, very simple. Okay? You just simply have to figure out what they are doing and comparing and contrasting. So today is the law of sines. Law of sines is going to be used with any and all triangles. You will not be using Pythagorean identities today. You will not be using any a squareds plus b squareds is equal to c squared. And the reason why is because we are not dealing with right triangles today. Does that make sense?
Yeah.
Okay? We are dealing with any type of triangle. In addition to that, you will be using degrees, minutes, and seconds. So you will probably need one of my calculators over there to do your homework this evening. If you are confused and you can't, because Desmos does not do degree, minutes, and seconds, no, you can get up and borrow one right now. There is a Calculator 84 app that you can use on your phone. That is a pretty good calculator. I will show you that app now so that you can see it.
How come there's a calculator on my Chromebook that says when it won't work?
Calculate 84, red, Calculate 84. It's the red one right here. That is the app that I'm talking about that you can download.
I clicked the calculator thing, you can download it on your Chromebook.
Does it work?
I don't know, let's see if I go to the Chrome OS and see if it lets me download it. We are sorry, but you do not have access to the Chrome Web Store.
Okay.
Okay, now with that being said, today the law of sines will be used only whenever you are using these special triangles, angle, side, angle, 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 side, and side, side, angle. Now, if you read some of these backwards, they spell words that we're not allowed to say. As soon as that happens, your brain needs to say law of sines, law of sines, law of sines, okay? Angle, side, angle, 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 side, or side, side, angle. Those are the three scenarios that you can use the law of sines with. If it's any other scenario, you may not use the law of sines. Does everybody understand what I just said? Okay, so with that being said, it's all about ratios, and it's on page 394 that you will have this. And here's what I'm going to tell you. Set any two fractions in the top row, any of those, equal to one another, cross multiply and solve. Set any two fractions equal to each other, cross multiply and solve. Set any two fractions in the bottom equal to each other, cross multiply and solve. Now, why is there two? You want to put the unknown that you are looking for in the numerator. It just makes life so much easier. So if your unknown is an angle, put your angle in the numerator. If your unknown is a side, put your side in the numerator. You with me? Any questions over that? Okay, now we have a few cases here. And these are right in your textbook with lovely examples attached to them, okay? Now, this says the ambiguous case. The ambiguous case is going to be side, side, angle. The ambiguous case is going to be side, side, angle. So as soon as you see a side, side, angle problem, you're going to say, hey, I have the potential for there to be two triangles, one triangle, or no triangles. What do I mean? If your A is acute, those are going to be your four options. It is going to take your acute angle, and then it's going to compare with the sides and the height. What is the height? The height is going to be h is equal to b times the sine of A. H is equal to b times the sine of A. H is known as the height or the altitude of your triangle. Do we all understand that? Okay? Now, given that information, you are simply going to say if it is side-side angle and it's an acute angle and A is less than H, then there's none. If A is equal to H, there's one triangle. If A is greater than B, there's one triangle. If your height is less than A, which is less than B, then I have two. And I'm going to be straight up honest with you. This one right here is the one that you're going to see a lot of in problems 15 through 20. Okay? The ambiguous case, which is problems 15 through 20, is where you're going to have two possible triangles. Do we all understand that? Okay? Now, with that being said, let's jump right into this. And immediately, whenever you jump right into this, your brain needs to draw the triangle, right? And you need to see what you've been given. So if I draw a triangle, and I label this A, B, C, and I go ahead and I label what I have. A is 30, little a is 12, and little b inside, angle B is 45. What did they give me? Angle, angle, side. Angle, angle, side. Is that the ambiguous case? No, it is not the ambiguous case, which means I can go ahead and use the law of sines on this.
Doesn't it matter where you set your angles up?
It does not matter where angle A, B, and C are, as long as the sides directly across from them are the actual side lengths. Does that make sense? Side A is across from angle A. Side B is across from angle B. Okay? Yes?
So these triangles are still 180 degrees, right?
There's still 180 degrees in it. Do not take this drawing for face value. It could be an oblique triangle or an obtuse triangle, which means obviously I did not draw it effectively there. Do we all understand that? Never, ever, ever take the drawing for face value. Trust your math. Any questions over what I just said?
But they'll always still add up to 180 though?
The angles will always add up to 180, yes, because it is a triangle. With all of that being said, you are always going to utilize the information that they gave you, which means this right here is what will be as part of my fractions at every time. That is the one ratio I will use. Side A over the sine of 30 degrees or the sine of 30 over side A. Does that make sense? Okay? Now, I need to immediately find B. So what I want to find is on the top. So B over the sine of 45 is equal to side A, which is 12, over the sine of 30. So how do I find side B? Well, you can cross multiply, or you can simply say, how do I get rid of the sine of 45 that's in the bottom?
Multiply.
Multiply both sides by that. So that means that B is going to be equal to the sine of 45 times 12 divided by the sine of 30. So I come over here, and I come over to Desmos, and I type it in, baby. And I said, what was that?
Sine 45 times 12 divided by sine 30.
And I hit enter. And it's not going to like it because I need to put parentheses around the 45 and around. You see how it's picky?
Why?
It just does that sometimes. I don't know why. You understood the same thing?
Yeah, zero.
Now, I am not in degree mode. I'm in radian mode, so I'm going to come over here and change it to degree mode. And since this is a side length, I'm going to round 2 decimal places to give me what value?
16.97.
So B is equal to 16.97. Do we understand that, yes or no?
Yes.
Now, how do I find angle C?
Well, the angle has to be 105.
That's going to be 180 minus angle A, which is 30, minus angle B, which is 45, and that's going to give me 105 degrees, which is left out of the 180.
So it'd be C over sine.
Does that make sense, yes or no? Now, what did I tell you were going to use every time? You always want to use what was given, because if you use your calculations, then you're going to potentially mess up and have errors. So to find C, I'm going to say C over the sine of 105 is equal to A, which is 12, over the sine of 30. Now, how do I find C?
Multiply by sine 105.
So C is going to be the sine of 105 times 12 over the sine of 30. So I'm going to come back over here to Desmos. I'm going to cheat, and I'm going to change this 45 to a what? A 105, and that's going to give me what?
23.18.
23.18. Okay, and that is done. That problem right there is going to be like problems 1 through 14 on tonight's homework. Like problems 1 through 14. Meaning, you are either going to have an angle side angle problem or an angle angle side problem for problems 1 through 14. Any questions on how to do 1 through 14?
So is there, you said they're going to be angle side angle or angle?
Angle side. Angle side angle or angle angle side. Okay, for 1 through 14. Any questions? Okay, that brings us to our next one, which is going to be our two-case solutions. Okay? This is going to be our ambiguous case, which is going to be our side-side angle. All right? Now, I'm telling you already that this is a side-side angle, but if you did not know, you would immediately draw the triangle, and here's going to be A, here's B, and here's C. Again, do not assume the drawing is accurate. It never is. Do we all understand that? So A is going to be 20.5, little a is 12, and then they give me B, which is going to be 31. This is going to be side-side angle because we are not going to say angle side-side. We don't use that in mathematics. We use side-side angle. Okay? So clearly, yes, sir?
The 31 would be across from the B.
Yep. Thanks, man. Thank ya. Side-side angle still applies. Okay? Thank you. I appreciate that. Okay? Now, any questions over that so far? All right, so now that we know we have the side-side angle, we have to do some comparing and contrasting, and we have to find some H values, yes? Because we have to look at this chart right here and say, hey, what do we have going on? Well, what we have going on is that A is an acute angle. So since A is an acute angle, we know that we are going to be in one of these scenarios. I'm going to clear this. We know that we are going to be in one of these scenarios. Does that make sense? Okay, because A is acute and it's a side-side angle. The next thing we need to do is we need to say, okay, well, what is A compared to B? Well, in our problem, what is A?
20.5.
Not angle A.
12.
12. And what is B?
31.
So that means that A is going to be less than B, so it cannot be this option, right? It could be this option, but we don't know about A and H. So now let's find H. Well, H is going to be equal to your B value times the sine of A. What is the angle A in our problem? 20.5. So we're going to come over here and we're going to take the sine we're going to have 31 times the sine of 20.5.
10.8.
And that gives you 10.86. You don't like being, there we go. So 10 is, H is going to be 10.86. So that tells you right here that we're going to have two solutions. Does that make sense? Okay? I showed you how that happens and how we're getting that. Yes? I found H, I compared A and B, and I said, hey, this means that I have to be in this scenario right here. I know that without a doubt I'm going to have two triangles. So your goal today is to find two triangles for this situation. So let's go back to our problem, and we are immediately going to find what first, do you think?
Angle B.
I would find angle B. So what did I tell you whenever we first did this problem? I said, put what you're looking for where? On top. So the sine of B, I don't know, and that's going to be over little b, which is 31, is equal to, what am I going to use now?
Multiplied by
Sine of 20.5 over 12.
Sine of 20.5 over 12. And how am I going to find the sine of B?
Multiply 31.
Multiply by 31 times the sine of 20.5 over 12. And now how do I find just angle B?
Inverse sine.
The sine inverse, very good. So angle B is going to be equal to the sine inverse of 31 times the sine of 20.5 over 12. Yes? Does everybody see what I wrote up there? Does everybody see what I wrote? Yes or no? We good? No. Just the microphone. Okay, so we're going to come over here and we're going to do some calculations. So I'm going to have sine inverse of 31 times the sine of 20.5 divided by 12 and hit enter. And what is that going to be? Round to the tenths, please. 64.8. So this is 64.8. Okay? Okay, now we're going to highlight this because we're coming back to this. And I'm going to highlight that so that you know we have to come back to that. That right there is what creates our second triangle. We're going to finish our first triangle, and then I'm going to come back to it for the second triangle, okay? Now, with that being said, the very next thing that you have to do is you're going to be like, okay, how do I find angle C? Come on, how do I find angle C?
180 minus angle A minus angle B.
So 180 minus 20.5 minus 64.8. What is angle C going to be equal to?
94.7.
Wouldn't that be like off though for surrounding?
Well, they're always going to be off because of rounding. Sine and trig is just like that. They're all going to be off because of rounding. But we're deciding to make all angles rounded to the tenths place and all side lengths rounded to the hundredths place. You with me?
Yeah.
Okay? So if we stick with that, they'll all be accurate based upon that information. Now that I found angle C, how do I find side C?
Just set it equal to the sine of A and
So this is going to be C over the sine of 94.7 is equal to the 12 over the sine of 20.5. How do I find C?
multiplied by sine of 90.
So C is going to be equal to the sine of 94.7 times 12 over the sine of 20.5. And if you type that in, what do you guys get?
34.15.
34.15. That is the first triangle. Okay? That is the first triangle. Does everybody understand that? Now, remember what I highlighted. I highlighted the 64.8. To find the second triangle, we are going to take 180 minus 64.8. Why? Because that's what our angle B was in our original triangle. So what is 180 minus 64.8? Type it in. We don't need mistakes.
115.2.
Very good. That is now going to become our new angle B. We're making this an obtuse triangle. Does that make sense? We are making this an obtuse triangle.
Where do we write this stuff at?
You're going to have to make a new page. There's not enough room on there. Okay, so now that we have that, the next thing we need to find is going to be, how do I find angle C?
Just do the same thing.
So to find angle C, I'm going to take 180 minus 20.5 minus 115.2. And what does that give you? 44.3. That is equal to angle C. Now we find our new C length. So how do I find my C length? So C is what I'm looking for, so that's going to be the sine of 44.3 is equal to my 12 over the sine of 20.5. Yes? So how do I find C?
Multiplied by sine of
what do you get for C then?
23.93.
23.93. And that is going to be the second triangle that you would have. This is going to be your first, and that is going to be your second. Okay? This problem is what you're going to do for problems 15 through 20.
Scroll down on the right side, please. Second
This is going to be like problems 15 through 20.
I was kind of confused on where you got the 115 now from.
I took the angle that we found in our first triangle for angle B, and we took that and took 180 minus that angle. Yep. That's its complementary angle. Supplementary angle, sorry. Okay? So that's how you're going to do 15 through 20. They will all be side-side angle, and you need to compare and contrast H, A, and B to figure out how many solutions you're going to have. Any questions over that? Okay, now the next one. The next one is going to be talking about the area of an oblique triangle. The area of an oblique triangle. Oblique means obtuse, right? And basically it says, if you have a triangle that is angle, side, angle. I'm sorry, side, angle, side. Totally said that wrong. If you have a triangle that is side, angle, side, they give you the angle in the middle of the two sides. Then to find the area of it, you're going to take 1/2 times the sides together times the sine of it. Doesn't matter which one it is. So you're going to take 1/2 times the sine of the angle times the two side lengths. Example. This is what I give you. If I draw the triangle, here's A, 5 degrees, 15 minutes. Here's B, that's going to be 4.5 across from angle B, and C is going to be across from that being 22. Side, angle, side. Do you see the side, angle, side? So since this is a side, angle, side, I'm simply going to say that the area is going to be 1/2 times the 4.5 times the 22, because those are the side lengths. Then multiply that by the sine of the angle included, which is going to be 5 degrees, 15 minutes. Yes? Do we see it? 5 degrees and 15 minutes. Okay? So you're going to come over here. I am not going to use Desmos because Desmos cannot do degrees, minutes, and seconds to my knowledge. And I'm going to go to a new page on my calculators, and I'm going to type in 1 divided by 2 times, what was my numbers again?
4.5.
4.5 times 22 times the sine. And then I'm going to come over here to the right of the 9. And to the right of the 9, you see degrees, minutes, and seconds. And that was 5 degrees, 15 minutes, and how many seconds? There weren't any, so you're going to put 0 there and hit enter. And it's going to give you an area of what? 4.53 or 4.5, which is what I think it rounds to.
I forget how you do it on these ones.
Give me a second. Okay? This is like problems 21 through 26. That is like problems 21 through 26. Okay? And tonight's homework is 1 through 25 odd. And I am done. Okay?
What was that? What problem was that one?
21 through 26.
21 through 26 is what those problems are like. Yes. Okay.